All right, in this lesson, we are going to review conics, which are our circles, ellipses, hyperbolas, and parabolas. And so, quick review of a circle. You'll recognize the circle's equation because the coefficients of the x and y squared are the same. And so when the coefficients are the same, you don't have any denominators. You set them equal to the radius squared. And so your center, x is with x, y is with y, and then the radius is going to appear on the right side of your equation. An ellipse, your coefficients are not the same, but they are both positive. And so in the case of a horizontal ellipse, the larger denominator will be under the x, because that's always going to give you your horizontal radius from left to right would just be a. So your horizontal radius from center to this side would be a. And then in the case of a vertical ellipse, it's going to, the larger denominator is going to be under the y. And so typically we always use a as the larger value. And so the larger value is a, distance from center to vertex. And then your center is still hk. Look for x with, to find the x coordinate, look for y to find the y coordinate. For a hyperbola, looks very similar. Only one of your variables is going to have a negative coefficient, either the y or the x. Whichever one has the negative, you're going to write that term second. And so you can tell you are working with a horizontal ellipse if x is positive, so we usually write it first, or we're working with a vertical hyperbola if y is positive, and so therefore we would write it first. And so same deal with the center. Look for x to find your x coordinate, look for y to find your y coordinate, and then you're actually going to have some asymptotes, and when you're finding your asymptote, it's always the change in y over the change in x. And so A or B could be on top depending on which variable is under the y. And then lastly, the parabolas. You'll recognize a vertical parabola if you have your x being squared, which is typical. We've worked with quadratic functions and we've seen x squared. They make a vertical parabola. Whereas we haven't worked with y being squared. And so if you see a y being squared, that's how you get your sideways parabola. And so opening to the left or the right. And then this a value is going to be given by a equals 1 over 4p, where p is the distance from vertex to focus. And then the other thing is your vertex is given by hk, and so be careful with the order. H will always be with x, k will always be with y. So the x is with the x, the y is with the y. Okay, and so looking at example 1, I know we are working with an ellipse because we have a plus sign. So they're both positive, but their coefficients don't match. One is 1 over 25, the other is 24. And so that's how we know we're dealing with an ellipse. And then we know we are actually dealing with a horizontal ellipse because the coefficient under the x is bigger. Okay, and so starting with the center, our x coordinate is 3. And our y coordinate is -1. It's always going to be the opposite of what you see with those variables. And so 3, -1. And then to get our vertices, our a squared value is 25. So that means a is 5. And that's going to be our horizontal distance because that's what's under x. And so we are going to go to the right 5. And we're going to go to the left 5. And to get our co-vertices, we look at what's under the y. So our vertical distance is going to be square root of 24, which is very, very close to 5 because it's very, very close to square root of 25. So go just under 5 units up. 1, 2, 3, 4. So just under. And then go 5 units down, but not quite to 5. So it's going to look very circular because they're very close in value, but that's why having the equations is so helpful. Okay, and so it says to identify the foci, and so we'll come back to that in a second because that requires, actually let's go ahead and do it. The C value is what gives us the foci, and for ellipses, the equation is a squared minus b squared is c squared. So in this case, c squared equals 25 minus, and then square root of 24 squared is 24, so 1. So c squared is 1, which means c is 1. And so we're going to go 1 to each side of the center along the major axis. The major axis is from vertex to vertex. And so our foci are really close to the center, which the closer you are to the center, the more circular this looks. And so one foci is 4, -1, the other is 2, -1. Okay, next we are working with a parabola because only one of our variables is squared and the y is being squared. And so I know we're working with a horizontal parabola. And because my a value is positive, I know it is opening to the right. And so going ahead and graphing the center, or the vertex in this case, the vertex would be 1, look at the x for the x coordinate, 2. Looking at the y for the y coordinate. So 1, 2. And then to get to the focus, we have to find the p-value. And so if a is 1/8, the formula for a is 1 over 4p. So we know 1 over 4p equals 1 over 8. And so you can think of this as cross multiplying 4p times 1 and 1 times 8. So 4p equals 8, which means p equals 2. And so we're going to go 2 units to the right to get to the focus. If this was a vertical parabola, we would go 2 units up to get our parabola. But here we're horizontal, so we're going 2 units right. And then that means the directrix is 2 units on the other side. The directrix is a line, the focus is a point, and they're always equidistant from the vertex. Oh, I didn't go 2. So that would be at -1. Okay, and so that's the directrix, and then our focus is 2 on the other side. And so now to get 2 more accurate points, we need what's called the focal diameter, or LR. And the formula for the LR is absolute value of 4p. And so in this case, absolute value of 4 times 2, which will give us 8. And so that's the diameter. So that means the radius on each side of the focus is going to be 4. And so 4 units up and then 4 units down, so that the whole length of the focal diameter is 8. And so the parabola is going to go through that top point. It's going to go through the bottom point. And since they asked us to identify the focus has an ordered pair of 3, 2. Okay, next they are giving us the graph and we are going to write the equations. And so I know I'm working with a vertical hyperbola here. Okay, and so to find the center, I think it's helpful to go ahead and graph the vertices. And so we have a vertex and a vertex here. And so the length of this axis is 3 to 7, so 10. And so halfway would be 5. So our center is -1, 2. And so I know I'm going to have a fraction bar minus fraction bar equal to 1. And because it is a vertical hyperbola, I know the y is positive. And so I'm going to have y first and then x second. And we have found the center to be -1 for the x, so we'll see a +1. And then we see +2 for the y, so we'll see a -2 inside those parentheses. And so next we just need to find the a and b value, and we actually already have the a value. The distance to the vertex is 5. And so we're going to have a 25 underneath the y, that's our vertical distance. And to get the b value, we need to find where the co-vertices are. And that's where it's helpful to kind of make a box. But for this one, I think it's going to be better to already see that we have the focus here. And so that's going to give us our C value. And so our C value goes from center to focus. And so our C value is 7. Okay, and so the formula for a hyperbola is c squared equals a squared plus b squared. It's the opposite for an ellipse. For an ellipse, it's minus. For a hyperbola, it's going to be plus for our c squared equations. And so we know a squared is 25, and we know c squared is 49. And so we now just need to solve for our b value. And so subtract 25 from both sides. We get 24 equals b squared. And so 24 would be the number underneath the x term. And that's all they wanted, so we can leave it just like that. Okay, next we have a circle. And first let's get the center. And so our center is -3, 1. And so we know our formula will be x plus 3 squared plus y minus 1 squared equals r squared. And so with this point, -4.5, 3, you can either make a right triangle to determine what r squared is, because this radius is a slanted line. And so you could make a right triangle using that point, or another way that we talked about in class is to just plug in the x and y coordinate into what we have so far. So we know we have x plus 3 squared plus y minus 1 squared. We know that's going to equal r squared. We don't know r, but that's what we're trying to figure out. But we do have an x and a y value. And so our x value is -4.5. Our y value is 3. And so when I plug those in, -4.5 plus 3 is -1.5. And then 3 minus 1 is 2. And -1.5 is the same thing as -3/2, which will make it easier for us to do the computation. We just square the top and square the bottom, so that gives us 9/4. 2 squared is 4. And then we can get a common denominator. 4 is the same thing as 16/4. And so we have 25/4 equals r squared. And that's what shows up in our equation. And so equals 25/4. If we needed the actual radius, we would just square root the top and bottom and get 5/2, which is 2.5. And you can see from the graph that it is about 2.5.